Hello and welcome to Know It All Haven. I'm Thomas, your guide to the wonders of science, nature, and everything in between. Today, let's dive deep, literally, into a question you've probably never thought about, but which shapes the planet as we know it. Why don't our oceans keep getting saltier and saltier, even though rivers carry millions of tons of salt and minerals into them every single day? First, picture this. Every rainfall, every drop of water that trickles over rocks and mountains slowly breaks down tiny bits of minerals. These minerals, including regular table salt, yes, the same one you sprinkle on your fries, are carried by rivers straight into the oceans. Since the process never stops, you might expect our oceans to become saltier with every passing year, maybe even turning into gigantic bowls of brine. And yet, the saltiness, or salinity, of Earth's ocean barely changes over millions of years. How is that possible? Let's start by asking, where does all the ocean salt come from? The answer is mostly from land. Rainwater is slightly acidic. It has just enough bite to dissolve minerals from rocks as it flows over them. The rivers then deliver this mineral soup into the seas. But there's more. Deep beneath the waves, undersea volcanoes and mysterious hydrothermal vents spew heat and chemicals, including salts, right into the ocean. And, believe it or not, even dust and ash from volcanic eruptions can drift through the atmosphere and land in the sea, delivering still more minerals. So if there are so many sources pouring salt in, why don't the oceans just keep getting saltier? The secret lies in what scientists call a balance of inputs and outputs, a kind of homeostasis for the ocean. For every dose of salt and minerals that rivers and volcanoes add to the ocean, natural processes are at work removing salt at about the same rate. Let's unpack how this delicate balance works. First, think about the bottom of the ocean. Minerals dissolved in seawater can react with other compounds and form solid materials. A great example is calcium carbonate. Think chalk or the stuff that makes up the shells of snails and corals. These solids are heavy, so they sink and settle on the ocean floor, trapping the minerals and salt for millions of years. This process, the mineralization and sedimentation of salts, indirectly removes the salt, locking it away as marine sediments. Secondly, tiny marine creatures like corals, shellfish, and plankton use dissolved minerals to build their shells and skeletons. When these creatures die, their mineral-rich remains drift to the ocean floor and become part of the sediments. In other words, the ocean's very own inhabitants act as salt and mineral vacuum cleaners. But how long does it take for this salty equilibrium to form? According to scientific estimates, it took hundreds of millions of years for today's oceans to reach their current balance. Some research suggests that the chemistry of our oceans stabilized around 200 million years ago. Before that, salinity would rise when more salt was added, and fall if removal processes sped up. But over vast timescales, nature always strives for balance. Even if some massive new salt source erupted, Earth's natural removal systems would, sooner or later, restore equilibrium. Of course, not all parts of the world's waters are equal. In some places, like the Dead Sea or other closed basins, high evaporation and little inflow make these bodies much saltier than the open ocean. But our great blue oceans are constantly churning and mixing their waters in grand currents, evening out the saltiness and making local changes quite rare. You might wonder, why does all this matter? The salinity of the ocean, how salty it is, actually has enormous effects. Life in the sea is incredibly sensitive to even tiny changes in salt levels. Marine species have evolved to thrive at a very specific degree of salinity. If that balance were to shift, it could ripple across food chains, even impacting the climate itself by changing ocean currents, which are powered by differences in temperature and saltiness. So, in summary, why don't oceans keep getting saltier? Because for every grain of mineral delivered by rivers, volcanoes, or winds, there are powerful natural processes working to lock that salt away deep beneath the waves. It's a delicate, majestic balance, millions of years in the making. and it's absolutely essential for life as we know it. If you enjoyed this exploration into salty mysteries, don't forget to subscribe to our channel, Know It All Haven, so you never miss a drop of fascinating science. Until next time, this is Thomas, wishing you curious days and salty seas.